All right, so we've got a bicycle. I've just drawn the salient pieces here. This is where the pedals are, so that gets turned by the bicyclist. The turning of the pedals will pull the chain, and so the chain is moving, and then the chain moving spins this back sprocket. This back sprocket is connected to the wheel, and so the wheel spins at the same angular speed that that back sprocket does. So the question is, if we're pedaling at 200 rotations per minute, so this is spinning over here at 200 rotations per minute, then the question is, how fast is the bicycle moving? Okay, so I am going to, first of all, so the information they give me, 19-inch diameter wheel, so the radius would be half of that. The back sprocket here is 3 inches in diameter, oh, sorry, in radius, and this is 7 inches in radius. So, so what I know is that this circle right here, this sprocket is spinning at 200 rotations per minute. I want to convert that first of all to um, radians per minute. So I've got 200 rotations per minute. And so now I got to multiply by an exchange rate. How many radians are in a rotation? Well, one rotation is worth 2 pi radians. And I set it up like this so that the rotations cancel out, and I end up with radians per minute. So this is now 400 pi radians per minute. So that spinning causes linear motion of the chain. That is, that the chain is moving along here, and I want to know how many inches per minute. Well, what I know is that on this circle, 1 radian of angle is worth 7 inches of arc length, right? Because the arc length formula was S equals R times theta. So if you got 1 radian of turn, then the arc length is equal to the radius times 1, right? Because the angle is 1. So I use that as the exchange rate. So the chain now, chain moves at, I've got the 400 pi radians per minute, and I'm going to multiply by each radian of turn is worth 7 inches of chain going through. As you turn that wheel, that circle by 1 radian, 7 inches of chain are going to pull through. Okay. So this is now, what's this, 2,800 pi inches per minute. So that's how fast the chain is moving. Well, that chain is now turning this wheel. And so I've got to now convert the other way. Here, 1 radian, if I do 1 radian of turn, it's only going to be worth 3 inches of chain. Okay. So the back gear, or the back sprocket, now it's got that 2,800 pi inches per minute of chain coming through, and I multiply that by each radian is worth 3 inches of turn, because the radius, remember, was 3 now. And I'm setting this up each time so that this, that here the radians and the radians canceled out to give me inches per minute. Now I've got inches and inches canceling out, getting back to radians per minute. And so the 2,800 divided by 3 is 28. What's that? 9, 3, 3 and a third times pi. And that's now in radians per minute. The back gear is connected to the back wheel, so that however many radians the gear turns through, the whole wheel turns through the same amount. Okay, so with the angular speed of the gear now being this many radians per minute, that's actually the angular speed of the back wheel. So the back, what just happened? Why is this jumping around on me? So the back wheel is also traveling at 993 and a third pi, sorry, not 993, 933 pi radians per minute. And I can convert that into inches per minute by saying, hey, on the back wheel, 1 radian of turn is worth 19 divided by 2. What's that? 9.5? 9.5 inches, right? The radius of the back wheel was 19 divided by 2, so 9.5. For a grand total of, what is that grand total? It turns out to be 27,855 inches per minute and some change here. So that, to me, I think is the answer, the first answer they asked for. And then they say change that to miles per hour. I would expect to know conversions like inches to miles. I don't think you should know inches to miles, but you might know inches to feet. Right? That would be 12. So let me try that. I've got 27,855.45 inches per minute. If I can get minute here. Times 1 foot is worth 12 inches. So I know that one. And I also know that 1 mile is worth 5,280 feet. Do I expect that you know that? I don't know. I kind of expect that you know that. It's the system we use. So this would turn it into, so the inches cancel out and the feet cancel out. I'm left with miles per minute, and the answer is supposed to be in miles per hour. So now I got to convert minutes to hours. Well, that's maybe not too hard. 1 hour is worth 60 minutes. And again, I put it this way so that the minutes would cancel out, and you're left with hours down on the bottom here. So if I take that answer that I just had, divide it by 12, divide that by 5,280, and multiply the result by 60, that should be in miles per hour. So let me try that. So on my calculator, I type that in and I end up with 26.378, whatever. This is now in miles per hour. Okay. Every one of these, it's a matter of realizing that the formula for arc length is related to radians, that the arc length is equal to whatever the radius is times the angle you turn through. So if you're turning through an angle of 1 radian every second on this circle, then you're going to be getting 7 inches of chain every second. If you're turning through 15 radians per second, then you're going to be getting 15 times 7 inches of chain, right? And we had a lot. We had 400 pi radians per minute. 400 pi is pretty big. It's like 1,200 some radians every minute. So 1,200 times 7 is that inches per minute, that chain that go through. That then feeds the turning of this one. And so the same number of inches per minute are going around this sprocket as we're going around that one, but this is a smaller sprocket. So it's going to be going around faster than that one was. Okay. Anyway, but still, it's a matter of each radian of turn here is worth 3 inches of chain. Okay. There you go, inches per minute. And my computer is dying.